Hai, assalamualaikum warahmatullahi wabarakatuh. My name is Mama Arash Najmi bin Tugimin, and my group mates Afif, Luqman and Zulfikri will do a presentation regarding our final year project, which is noise monitoring.
Hi, my name is Muhammad Zulfikri bin Azizul Rahman, and now I will be continue with the abstract. So for the abstract, voice monitoring includes a voice monitor device that will display the volume playing when the voice is captured. This research aims to raise awareness about noise pollution and its devastating effect on the human ear and the environment, which will be conducted in several working areas. This study is a quantitative study by collecting data of the sound level in decibel at high-risk environment by measuring the conduct area measurement, noise counter, and personal noise exposure monitoring. This study finding is the sound level at some high-risk site is detrimental for the worker near the site. However, as some of the measurements are taken a bit far from the actual site, the decibel is lower than the expected decibel unit. Yet, the result may thus how show that place with high risk sound has higher decibel than the recommended decibel.
Voice monitor is a view display the volumes playing in time when capturing with the profiler. The use of this device also can detect the voice that playing in our environment, and which also can record the noise pollution that occurs. Noise pollution defined as regular exposure to elevated sounds that may lead to adverse effects to humans and also living organisms. Based on the World Health Organization's noise that less than 70 decibels will not harm the living organisms, even though being exposed for long hours. Unfortunately, there will be side effects if living things or humans expose themselves more than 8 hours straight to the 85 decibels sound level. This is like exposing themselves to the mining machine for 8 hours straight. The worst noise pollutions, especially for humans, is a jet taking off, where if a human's standing 25 meters from the jet, and the sound levels will reach about 150 decibels, which is extremely harmful for them. Noise pollution leads also to noise-induced hearing loss, where it is a term that caused from excessive loud sounds and cannot be medically or surgically corrected. That's all for the introduction.
Hi, I'm Afif, and I'm going to be talking about the literature review for this case study. From our research, we have found that at least 25% of hearing loss are actually noise-induced hearing loss. Noise-induced hearing loss is caused by long exposures to loud sounds, like above 85 decibels. And we found that at least 30 million people are exposed to these loud sounds at work. Examples of these dangerous workplaces are construction sites, racetracks, and traffic roadside assistance. And speaking of traffic noise can actually make people lose concentration at work and even lose quality of sleep. And noise pollution not only affects us as adults, but it has been found to also affect the growth of young children. And as a species, loud ships were also found to affect the internal organs, as sound waves travel faster in water, which can disrupt their way of life, causing whales to beach themselves.
Hi, so right now I will be continue with the methodology. So for the methodology, we separate into 3 parts. First is research design, second instrumentation, and the last is data analysis. So for the research design, our type of study is quantitative study. We need to measure the data by do some recording to collect the data. We are using mobile application that named as Decibel X. That application was so convenient and have a lot of features to help us collect the data. We also use augmented reality application to measure the distance between the source of sound to certain distance to measure the sound from the source is harmful or not to the people that living nearby. Next is instrumentation. First, we have sound of level monitoring. Monitoring is defined as monitoring of sound level in unit decibel around a certain area. In this study, noise level are measured at high risk environment to see if there are levels in which are considered harmful to the employees. The distance of monitored area is also measured to record the radius of the affected area. The monitoring area is also calculated to measure affected area. Next we have sound level. Sound level were recorded by the student going to site and using an application called Decibel X on their mobile phone to record the sound level in unit decibel. The sound level is measured in 3 different lengths from the source: short, medium, and long, to observe the dampening of sound level. The value of this length varies as different sites have different restrictions due to authoritative and safety factor. Next, we have distance from source. The distance from source of sound is recorded along the sound level to measure the radius of the affected area. The distance is measured using augmented reality application on student mobile device called to measure 3 different lengths just like sound level. This is to observe the how far it takes for the sound to dampen, and since sound travels in a circle from the source, the distance can be taken as the radius that the sound travels. Next, we have area monitored. The area monitored is calculated by insert the radius collecting from the distance measured to equation pi r square, which is the formula of the circle. This is to calculate the area which the sound level are affecting as sound travel evenly from the source in circle if not interrupted. This will help determine how big the affected area and how many people it might affect. Last, we have data analysis. Since the noise is recorded in dimension 2D, we need to use formula pi r square since the noise travel in the circle. Students refer the example of area monitoring from the Industrial Noise Control Module from Department of Safety and Health Malaysia.
Hi, assalamualaikum warahmatullahi wabarakatuh. My name is Arash. I'm going to talk about the results and analysis. The data that have been recorded by the students are shown in the table that generated from this Microsoft Excel. The students do the collection of data at different types of places, such as the construction site, the railway station, and the airport. In addition, the data collected by the students are near to the residential area. This will show how harmful noise that will affect the residential area, that if they exposed to high decibel sounds, which is above 85 decibels. After collecting the data, students will do the calculations for the area monitoring. The area monitoring is calculated by using the formula pi r square. The reason this formula is used because noise travels in a circle and students record recorded this in two-dimensional shape, and that's why this formula is used. Furthermore, students cannot enter the construction sites because they did not have the CIDB Green Book. In order to record the data at the venue or the location that they want to, they have to be outside the construction area and record the data by using the application Decibel X. This application shows a quite accurate sound recorded, and it is a friendly user to the students. During the recording of the data, there may be some errors that will occur, and the most relevant error that will occur is the vehicles that will interrupt the sound of the Decibel X application. Now I'm gonna explain about a few places the students record the data. So the first one will be the construction site 1. At distance 20 meters, the students calculated the area monitoring is 1256.64 meters square. At distance 40 meters, 5026.55 meters square, and at distance 60 meter, the area monitoring recorded will be 11,309.76 meters square. At the airport, at distance 100 meter, the area monitoring recorded will be 31,415.93 meters square. At distance 140, 61,575.22 meters square, and at distance 180 meter is 100,001,787.60 meters square. Next, for the KTM Subanjaya, at distance 15 meter, 706.86 meters square. At distance 30 meter, 2,827.43 meters square. And at distance 60 meter is 11,309.73 meters square. Finally, at Jalan Kuala Krai, at distance 30 meter, 2,827.43 meters square. At distance 50 meter, 7,853.93 meters square. And at distance 70 meter will be 15,393.80 meters square. Thank you very much. That's all for the results and analysis.
Hi, I will be talking about the discussion for this case study now. As you can see from the data analysis, the area monitored for the sites actually differ from one another in terms of short, medium, and far. This is because of the different levels of access granted to the students at specific sites. For example, in construction areas, students were allowed to run around the perimeter but weren't allowed anywhere near the source because the students weren't in possession of green books, and for safety reasons they cannot allow anyone without a green book inside the premises. For the racetracks, only marshals, team members, and drivers were allowed into the paddock and recording the cars. So the students had to stay at the grandstand to record the data. And for the airports, you can see that the shortest distance able to be recorded was at 100 meters. This is because the runway is very far away from the fences guarding the airport. And we can also see that from the sound level data that even though the distance is very far from each other, some of the sound level data do not differ as much. This is because some of the sound level data, especially the ones far away, are actually tainted by sounds from incoming traffic, weather such as rain, and even strong winds. But we can counter this by inserting the values from the shortest distance nearing the source of the sound into a sound dampening calculator. What this does is it actually calculates and predicts the most accurate sound level of only the pure sound at a much greater distance, leaving out all the interrupting sounds. In conclusion, now noise-induced hearing loss is indeed a huge problem and needs to be addressed as a serious matter, because a lot of people do not realize this, as even though it poses a threat in the long term. Traffic noise may not be as dangerous as the other noise pollution, but it certainly does disrupt the quality of life, even to go as far as disrupting the growth and learning abilities of children. Racetracks, train stations, and airports have been proven to be very dangerous in this case study, and employers should take steps in providing better protection gear for the employees, and also introducing ways to reduce the sounds of the machineries at work. For the ecosystem, guidelines should be introduced by the Coast Guards into how loud the machines are allowed to be, how loud the submarines and ships are allowed, so that we can help reduce the impact of human activities on other species. And that's all from me. Thank you.